This is going to be homework right up here. This is going to be homework 2.6, 19 through 31, page 105. Quadratic formula. The quadratic formula is this formula. Most of you have had me, Antonio, you haven't, so there's some symbols up here that you might not understand. One, this stands for if, and this stands for then. So basically what it's saying is if ax squared plus bx plus c is equal to 0, then x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And what we're doing is we're trying to find what's called the zeros. Okay? When y is 0, or when f of x is 0. So when f of x is equal to 0, or y is equal to 0, this is what solves it. Okay? This is what's going to help us solve it. Alright? I'm going to erase this a little bit. It's a little bigger. Okay. So, in order to do this problem, right, we have to put it in the ABC formula, right, Jordan? So which one's A, B, and C? Right? Tia, which one's A, B, and C? A would be in front of x squared, yes. Now, the thing is, like we were learning last week, we were doing this a little bit on that practice test, right? And we're not supposed to put in the x's, right? So the one thing we have to realize is, one, we need this to be set equal to 0. Two, we need to realize that there's a number out in front, right? When there isn't. When you don't see a number, there really is a number, right? And when you don't see a number, there really is a number. I mean, this is everything we got to learn today. Is when you don't see a number, there really is a number. Okay? The first step to that is 1x squared, right? There's a 1 out in front. The second part to that, I don't see a number adding on to it, do you? I don't see a C. There's an A, there's a B. Where's the C? Right? So I make one up. I don't change the problem, right? I didn't change the problem by putting in a 1, correct? I didn't change anything, right? And I didn't change the problem by adding a 0 either. Does that make sense? I didn't change anything. All I did is organize it. Math is all about organization. If you do not have organization, it will be difficult. That's the whole purpose of the upside down division. Organizing. That's the whole purpose to creating cheat sheets. Organization. Without organization, we tend to folly. Okay? So, with this, I can look above it and go, now I can see A, now I can see B, and now I can see C. Because this is all equal to 0. Sorry. Equal to 0. I'm trying to find these zeros. I'm trying to find where this crosses the x-axis, right? I should know that this is a quadratic, right? The parent function is f of x is equal to x squared. So it looks like this, right? Except it's shifted. I should be able to look at this and know that. Why? Was the first test, right? The first chapter says parent functions. Oh, there's a square. Okay, it's a quadratic. Okay? So we should be able to look at this and know right away It's a quadratic. It's not frowning because there's not a negative out in front. Okay? So it's smiling. And it looks something like this. Now it's going to be shifted. It's going to be stretched. It's going to be compressed. Something, right? But it looks like this. This is the parent function, and this is grown from that. Okay? And then what we're going to do is find where it crosses here. I mean, because if it's like this, then it doesn't cross the x-axis, right? And if it's like this, then it crosses twice. Okay? Once here and once here. And if it's like the x, it only hits one time. It's right there. Okay? So, it's either crossing once, twice, or no real crosses. Okay? So, let's get back to this. Let's do the math. Let's plug it in. Okay? So, I have this formula. So, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? And then you just start plugging these numbers in. b, a, c. Okay? And then, once I'm able to do that, I can do the math. Negative 6 squared. Jordan, 6 squared. Jordan, why do you have no notes in front of you? Why are you talking to the person next to you, stopping them from taking notes? Please get your notebook. Please get some pens. Please pay attention. 6 squared. Anyone, somebody, one buddy.
36.
There you go. Now, I kind of look at this and I go, well, if I see a negative here, I want to see how many more negatives I see. In this case, I don't see any more negatives. Okay? So it's just minus. And then I do the math. 4 times 1. 4. 4 times 0. 0. So I just have 36 minus 0. Okay? All over 2 times 1, which is 2. Okay? So what that does, it brings me up, I'm going to have to make another page. And does anyone remember what that was? X was equal to, wasn't it negative 6 plus or minus the square root of 36?
Yeah.
All over 2. And then we had a minus 0, but if we go to the next step, we could just say it's 36, yeah? Okay, we're all good here? We all know where we came from? We all know where we're going. Okay? Next. I need to do the 36. What's the square root of 36? If you don't know how, we do the upside down division. Okay? 2 goes into 36. Was that 18 times? 2 goes into 18. 3 goes into 9. 3 goes into 3. Right? Then we pull out our pairs, right?
Why didn't you do it by 6?
Huh?
How come you didn't do it by 6?
Not a prime.
Is that a prime?
No.
Remember, we break it down by our primes. So we're going to use 2, 3, 5, 7, 11. This is our core. Okay? That should be on your cheat sheet. That's your core. That's what we're going to use over and over and over and over this year. We're using prime factorization so much from now to calculus that you need to know these primes. You need to know this upside down division. Most schools do not teach it because all they teach it for is prime factorization. Okay? But I use it in how I teach all my factoring. Okay? All my GCF factoring. Which goes from here, in this little place, to finding square roots, to finding cube roots, to finding the power of 3/8, to being able to do trig, which is sine squared plus tangent squared equals sine minus cosine. Okay? And then you can start factoring out some things, which we will get to. I think we got to last year, a little bit, in geometry. This year you get to it at the end of this class. We'll get to trig identities. It's going to be real helpful. Alright, so what is 2 times 3? 6. And you should know by now that the square root of 36 is 6, right? But if it were the square root of 38, you do the same thing. If it's a square root of 40 or a square root of 48, you break it down. Whatever is circled, whatever is paired up, comes out of the box. Whatever is not paired up, like this guy, stays in the box. But what's the square root of 1? 1. And what's 1 times 6? 6. That's why we don't really worry about the 1 here. I only worry about what's in the column. So if there's some numbers left off in the column, if there's a 2 and an 8 left off in the column, then now you have the square root of 16, which you wouldn't have because, there's not going to be an 8 there. But a 2 and a 3, or 2, 3, and a 5, right? Because those are all primes. Now you're going to have square root of 30. 2 times 3 times 5. Okay? Alright, so we have this. Let's change the color back to black. We got x is equal to negative 6 plus or minus 6 all over 2. And now we go in 2 directions. Okay? 2 directions. One direction is plus. Right? This guy. So I'm going to go negative 6 plus 6 over 2. The other direction is minus, or this guy. And I'm going to go negative 6 minus 6 divided by 2. Okay? And then negative 6 plus 6 is 0, right? And so I get 0 over 2, which is 0 or undefined. Because this is where students get confused. 0. Remember, 0 on top is okay. 0 on the bottom, not okay. Right? We can't have a 0 in the bottom. But we can have a 0 on the top. It just equals 0. This guy is negative 6 minus 6 minus 12 over 2, which is equal to negative 6. So x is equal to 0, negative 6. Now technically, I should write those in order. Order meaning negative 6 and 0. From lowest to biggest. Okay? And that's problem number 19. Okay? Now we're going to speed it up a little bit and look at problem number 21. Okay? Problem number 21 says this. I'm going to set this equal to 0. I have an A, B, and a C, whereas x is equal to this negative b plus or minus the square root of b squared minus 4ac all over 2a, right? And then I just start plugging in the numbers. My b is negative 2, okay? My a is negative 1, okay? And my black is somewhere else. right up now. So we'll put a lip on there. And I can put my C in. And remember, I'm taking not the X's, but I am taking the signs. Right? I am taking the signs. Right? And if you want, you can put the signs in there. All of them. I don't care. Right? The point is, these are all multiplied. Okay? So, what is negative 2? Positive 2. Square root of negative 2 squared. So negative 2 times negative 2 is 4. Yeah, positive 4. Okay? So this one's always going to be positive, no matter what it is, right? And this is always going to be the opposite of what it is. If it's negative, it's going to become positive. If it's positive, it's going to become negative. This, look at this and this. We have 2 negative signs. 2 negatives make a positive. I always do those first. You don't have to. You don't have to. You could say negative 4 times negative 1 and get 4. Positive 4. But I like to just look at this, go, how many negatives I got? If I've got 1 negative, it's negative. If I got 2 negative, it's positive. If I have 3 negatives, it's negative. Okay? And then I just throw it down. And then I do the multiplication. 4 times 1 times 9. 36. Is that right? Yeah? Okay. Over negative 2. Alright? And then add those up. So I got 2 plus or minus the square root of 40 over negative 2. Now again, we do this negative 4 or this 40 the same way we did the 36. We break it down. You're going to get a lot of these where they're not nice. They're not 36 or 81 or 49 or 121 or whatever it is. Okay? They're not perfect squares. Okay? And you have to know how to break them down. 40, 2, 20, 2, 10, 2, 5, 5, 1. You're done. It's not hard. Should have been doing this since like 7th grade. Right? For most of you have been doing it since last year. So, but we've been doing it, and that's what's important. Right? Pick the pairs. This makes it really easy. If I start at the top, now I got a 2 here, right? Now I don't have any other pairs. So I've got to throw whatever I don't have in the box. 2 times 5, which is, and this is why I do this. Because you usually end up with it telling you what it is. So you don't even have to worry about it. You look at it and you're like, okay, this is 2 square roots of 10. So I'm coming over here and I got 2 plus or minus 2 square roots of 10 all over negative 2. Now here's the thing. I have a negative in the bottom. Okay? I need to figure out how I'm going to get rid of the negative in the bottom because I don't like negatives in the bottom. We want to bring that negative to the top. The other thing I want to do is get rid of the 2's. Right? So what goes into 2, 2, and 2? 2, right? It's pretty common. But I want to get rid of the negative, so negative 2. Okay? Now, negative 2 goes into 2 how many times? Negative once, right? Okay? Now, the way this is it's going to make this positive into a negative and this negative into a positive. So basically it flips that sign. But you don't have to flip the sign. It doesn't really matter. It's still a positive negative, right? But it goes into this 2 once. It doesn't do anything to this. Okay? Nothing. It doesn't touch it. This is a barrier. This is a blocker. This is a shield. And this arrow cannot get through. Okay? Negative 2 goes into negative 2 how many times? Once. Now, I like to clean this up. I don't like to see all these ones. So I clean up the ones that I don't need. But I keep the ones that I do. I have to keep this guy, man. You can't get rid of that. That's a negative 1. Plus or minus. I like to clean up this. This is a plus or minus. We don't never write it as a minus plus. Right? I'm just writing it like that so you can see that this became a negative and this became a positive. It doesn't look like anything changed there, but it did. Okay? I don't need this 1. So I put in a square root of 10. I don't need that 1, so I'm done. Okay? And what this is telling me is that my axis of symmetry is negative 1. How do I know that? Well, because I was working with somebody the other day and we were like, oh, let's look at this, well, let's understand it. And I'm like, yeah, it should come up as negative 1. Why? Well, because it's plus or minus. It should be the same distance from the axis of symmetry, right? These are 2 points on the graph. And they should be the same distance from a point. They're the same distance from that point. And it looks like this. And if we look at this, if we take this, this is negative 2, right? X minus 2 equals 0. Negative 2x equals 2. So x is equal to negative 1, right? And that's your axis of symmetry. That's what we've been doing. And that makes sense. So I did this right. This is a really nice way to check if you're doing it right. Because if you get a number, plus or minus a number, then that number should be your axis of symmetry. Does that make sense? Now if it's divided by something, then, well, we got to check out the way, change the way you're looking at it. All right, next. This one. Again, we set it equal to 0. But in this case, I need to rewrite it. 7x squared plus 0x minus 3 equals 0. Why did I put 0x? Because there's no b. Because there's no b. I need a b. Give me a b. I don't even know how to do that. So, but, right? I need a B. I need an A, I need a B, and I need a C. If I don't have it, I can't plug it in. Okay? So then I've got negative B plus or minus the square root of B squared minus 4AC all over 2A. Right?
If you put just the x there, wouldn't it be 1x though?
If I put just the x there.
Instead of 0x?
No, I can't just add an x and say it's 1x. That would change the formula. Right? That'd be like adding a 4 to it or something. I can't change it. But if I added a 0 to it, then it doesn't matter, right? Well, and I'm adding a 0 here. I'm saying 0x because I'm just saying, hey, there's an x, there's actually an x in there. It's just hidden. And what's funny is, all your lives, you were taught 4 plus 7, right? 4 plus 7. What is that? 11, right? But would you believe me that this was really 4b to the 0 plus 7b to the 0, or